The ability to be able to add distributed networks to your current automation system gives you scalability and flexibility that can be a huge advantage. Let me show you how easy it can be. So as you can see, in our current automation system, we have a controller and an HMI panel, so let's add some hardware to it. So I want to give focus to the main CPU first, and I want to check off this box of support device replacement because some field devices don't have that capability. Now what I want to do is give complete focus to the CPU, double click on them. The moment I've got complete focus on him and this filter box checked, that means that only the available cards for this actual local rack are available to me in the hardware catalog. Let's go down and find the Profibus master card. Let's drag it into the project. Now I have him. If I have focus on him, of course I could change an attribute, but in this particular project I'm not going to. So there, back at the network view, I have my CPU and the master module. How about the actual distributed architecture hardware itself? So I have this E200S rack here, and I have the ability, for instance, from a global library standpoint, to save an entire rack of I/O, including the attributes, to the global library. And as I have common machines come online, I can go grab that rack, drag it in the project, and I'm done. Let's go to the global library real quick. Let's go grab this rack and drag it into the network view. There it is. I can double click on it, and for instance, if I want to change an attribute, if I double click on it, there's the properties. I want to change the Profibus address to 3. And here's all the associated cards that are in this particular rack, including, even if we have an analog card with a 420 milliamp, 0 to 10 volt, whatever attribute is with it, comes with it. So let's go back to the network view. The next logical step is networking. So let's just mouse over the Profibus interface of this rack. Let's drag it to the master module. When I let go of it, it'll auto-create the logical physical connections. The Profibus network is done. Let's move on. Okay, Profinet. Let's go back to the hardware catalog. Let's go choose Distributed I/O, E200SP. Let's go to Profinet Interfaces. There we go. Let's drag that onto the network view. There it is. Double click on it. There's the photorealistic view of it. And since I've got focus on it and the filter box is checked, I can go search for this local rack and hardware that will go in it. So an 8DI card, 8-point DI card. Let me drag that in the project. 8DO card, let's go grab one of those, drag that in the project. And if I want to terminate this I/O rack, I just go grab a servo module, drag it on, and now the I/O rack is complete. Okay, let's go back to the network view. How about networking this to the Profinet side of this system? So let's just mouse over the interface of it. Let's drag it onto the master module of the CPU. It auto-creates the Profinet network to the master, including logical physical connections, IP addresses, device names, everything's done in the background. The Profinet network is done as well. Okay, how about assigning this I/O device name? So let me give focus to the E200SP rack. Go down to Assign Device Name. So this particular rack, from a Profinet standpoint, has an IP address and a device name. What's important about that is that's how the master addresses all the field devices. So we're going to have a dialog box here, and with this dialog box, it's going to give us the ability to actually see all the Profinet I/O system architecture hardware out there. And once we have it, here it is, we can actually assign the name. If we go and give focus to it, click on Flash LEDs. This is the correct rack that we want to assign a device name, so let's assign it. So at this point, it's going to go out and scan the network again, try to find that hardware, give it his device name. And then I can click on the refresh button. I'll scan the network and make certain that it physically has been assigned. It appears as if that is correct. Okay, so I can give focus to the main CPU, click the download button. So now we'll actually go back and compile the two different networks, Profibus and Profinet, including the associated hardware we put on it and all their attributes, along with all the current system hardware that we have, including the code. Once he's finished compiling all this, we can load it to the system, and we should have a fully functional networking system here. I click the load button, so now he's actually loading to the physical hardware itself. And I click Finished, and as you can see, we have all green LEDs here on the two different I/O architectures and the main CPU as well. Okay, so let's prove that this system is up and fully functional. If I just give focus to the main CPU and click Go Online, the way you'll know that is we'll have the orange bars across the entire top of the software. And also too, we'll have all the green check marks so we know all's well. If I come over to this Profibus E200S rack, go grab a card and pull it out, you'll see I get a bunch of red LEDs all over the place. If I come down to the device information, if I just click on this right here, it'll automatically take us to the diagnostic buffer. And as you can see, it is an incoming message. It is an error for rack 0 slot 4, and it says this hardware component is removed from that particular rack. That is correct, so I can solve the problem easily. Let me put this back in the rack real quick. Problem is now solved. Goes back and it scans everything, and we have an outgoing message, and everything is now green LEDs. So basically, we have the ability for all of our hardware, 1200, SP, E200S, to have every single layer of potential diagnostics from the channel all the way to the entire rack, and you don't have to program one line of code to get any of this. Okay, so the next step is, let's go offline. Now that it's offline, how about control? It sure would be nice if we could do some actual control over one of these networks. Let's do it over Profinet. Let's go back to the device view, and let's go to the hardware catalog, and let's choose HMI, KP8. That's the correct one. Let's drag this on. So this is the key panel 8 that we're going to use in this project. Let me give focus and mouse over to his Profinet interface, drag it to the master module. Again, it's going to create the IP address, device name, logical physical connections, everything in the background. Let's give focus to him and click on Assign Device Name. So just so you know, this KP8 does have these 8 keys with backlit LEDs. So we have complete control functionality through them, as well as associated inputs and outputs that we could wire. And it's treated as a Profinet I/O device. So now the dialog box is going to pull up. So here is a dialog box so we can assign a device name. There's the KP8. Let me assign it. And let me go back and hit the refresh button just to make certain that it actually has assigned the device name to that. It did. So let me close that out. So how about actually creating the control from this KP8 to the standard control we already have in the CPU? If I double click on that KP8 and just hit this little button right here, we'll see that we have the byte 6 and 7 for the inputs, and byte 9 through 12 are the outputs. So if I go to the main program, launch it. So now here is the main program that we've already been using in the current system. Let's go to the start. Let's just go click on rewire tag. And I know that this is going to be byte 6 dot, this is 0 through 3 and 4 through 7, so it will be 7. Let's go to the stop, rewire tag. This will be 6.3. So now I've got my standard control. How about actually doing something on enunciation? So let's create 2 more quick networks. 1, 2. Let's go grab a normally closed contact as well as a coil. And then I can go grab this motor 1 and hit control and drag it to this first tag. And then I want to use the global library concept again for our tags. You can create a tag database, save that to your global library, and as you pull in the hardware, you could also pull in the tags. That way you can tie them together and be up and operational quickly and efficiently. Let's go back to the library. Let's go grab our tags. Let's drag in the PLC tags. So there's our start. Let's go copy and paste this whole entire line of code into the second line. Then I need to change the contact to a normally open because I have to have the inverse state. Let me delete the start and go drag the stop tag over here. Let me give focus to the CPU, click the download button. So now it's going to compile this new field device, the KP8, including what I put them on Profinet, as well as all the new code changes I've made. Once it's finished compiling, then we can click the load button. Now it's going to load all that down to the system. And in fact, we should have a fully operational KP8 on Profinet and have full control over the current system in just a matter of seconds. Let me click Finished. As you can see, the LED is working and functioning fully at this point. I can click Start and have complete control over my current system. And I can click Stop, and I did this whole thing in just a matter of minutes. Now that's engineering efficiency.